For the pulse position method and secant method, we can now see the difference between the two. The XL, XU, XR represent, and for secant, it represented as XI minus 1, XI plus 1, and XI. So, it's like it's almost similar, but the graphical representation would be different. So, for the XR is equal to XU minus f of XU times XL minus XU all over f of XL minus f of XU, and the crossover representation of that is X I plus 1 is equal to this formula. So, as we can see, and for the example, f of x is equal to x squared minus 2 used for iteration using false position and secant negative 0.5 and 2. So, if the calculated approximation error would react to the value of less than 0.5, then it means that your iteration process would be possibly on the nearest estimated roots. So, in this way, the value of XL and XU always bracket to the true roots. The process is repeated or make an iteration until the root is estimated. So, applying for this example, XL is equal to negative 0.5 and XU is 2. So, by finding the XR, you have to substitute it to this formula and become the formula is 2 minus 2 times 0.5 minus 2 all over 1.75 minus 2, and the answer is 2.3. And for this part, the second method usually or similarly for this given is XL is similar to XI minus 1 and XU is similar to XI. So, by finding this, you have a value 2.2 over 3. So, this is the graph that represented, this is the table represented for this pulse position and secant method. So, we can now see the different, we now see that it is also similar for this example. So, by getting, as I said previously, if the calculated error approximation would reacted the value of less than 0.5, then it means that your iteration process would be possibly on the nearest estimated root. So, by using this part for iteration, we can now use so we now prove that at the fourth iteration would have a value that would be possibly in the nearest estimated roots, 0.2979%. That's